आप यहाँ से शेयर स्क्रीन कीजिएगा, प्रेजेंट नाउ कीजिएगा तो
शेयरिंग भूल गया था, फिर बाद में हुआ। ठीक है, 2 मिनट रुकना, शुरू हो जाएगा। हेलो,
Good afternoon. Good afternoon, sir.
Good afternoon. Good afternoon to everybody.
Today we have experts from the Professor SP Singh, sir, from IIT Day2. SP Singh received his BE and ME in Electrical Engineering from Allahabad University. Presently, MNIT Allahabad, Prayagraj, India, in 1978 and 1981, respectively. He obtained his PhD from BHU in 1990. He was postdoctoral fellow as Boycott Fellow awarded by the DST Government of India at the University of Calgary, Canada during 1993-94 for 1 year. Beside, he has been a visiting fellow under Royal Society INSA Exchange Program at the Burnell University, Newbridge, London in 2004 for the 3 years, for 3 months. He joined the Electrical Engineering Department of BHU as a lecturer in 1981, where he is presently serving as professor. His main research interests are in optimal operation,
You are not audible.
He has published several research papers in international and national journal and conferences in above mentioned area. Dr. Singh is a fellow of Institution of Engineers, senior member of IEEE since 1994 and life member of System Society of India. He has been head of Department of Electrical Engineering, IIT BHU during 2012 to the January 2015. Apart from, he has shouldered many other responsibility of the university and the institute. I welcome you, sir, in this faculty development program on smart technologies and communication protocol in power system. So, please, sir, I request you, please start your presentation. Thank you, sir.
Thank you very much, Dr. VP Singh, for introducing me. Very good afternoon to all the participants, maybe from various institutions of the country. How many participants are taking part? 31. Hello? Dr. VP Singh, there are 31 participants perhaps. Hello?
Sir, voice is coming?
Yes, yes. What about me? Am I audible?
Yes, sir, you are audible, sir. Audible. So, more participants will join, sir. Actually, before your session, one session already finished at 11:30. So, participants are joining. So, they will join, sir.
Maybe there was a tea break.
Tea break finished, sir. So, till now, 31 have joined.
Tea break before. But yeah, they are all from distant places.
Yeah, sir.
शेयर वाला भूल गया था. Stop here. Right. Is it visible?
Yes, sir, it is visible.
Okay. So, seeing the overall topic of the program, I thought to include the method or a lecture which can incorporate the uh, communication infrastructure as well as some part of artificial intelligence and the open access which has been adopted by most of the countries in the world as well as India. You know, the focal point of the open access is to generate, transmit, and distribute the energy, taking economic aspect and the technical aspect into account. In this direction, I thought the available transfer capability evaluation may be a suitable topic for this course because every utility and operator would like to run their system to have the available transfer capability to its maximum so that it can serve to the load to maximum extent. To explain what ATC is, I have taken example of a simple demonstration through a small system of 4 bus where the load exists at all the 4 buses and there is generator at 2 buses toward the left hand side, the load as well as generation. However, at these 2 buses, there is exclusively load only. Now, if you and the 2 lines shown by white and green part shows that the white part represents the margin available. Margin available means there is capacity shown by this. It is not in exact proportion, but it just shows that there is margin in these 2 lines which can carry additional power, and the green part shows that this much load exists at the present loading condition. Of course, only 2 lines have been considered for the demonstration purpose, and this has no meaning, but these 2 lines are also loaded. But since this diagram has been taken for the demonstration viewpoint, I have considered only 2 lines for explanation viewpoint. Now, under the fault condition of line 1, the circuit breakers of 2 ends of the line will disconnect. As a result of fault in line 1, the scenario from the previous condition to the faulty condition will change, and the other line will have to carry more power because of the power which was carried by the faulty line is redistributed in the network, resulting in a greater power flow in the other line. Of course, as I said, these two lines which are shown black are also affected, but since our consideration was to demonstrate how the change scenario will affect the system from the viewpoint of loading. This is another example in which the other two lines have been considered, and the situation shown by green and white lines, white part has the same meaning. And in this case, to the previous case, the difference is that in this case, there are three generators at this bus, and because of the outage of one of the generators, scenario power flow in these two lines have changed, and the this line is close to its capacity, and little increase in load may cause overloading on these lines, but the other line has still margin to carry more power. The other example in which at one of the nodes, the generator connected to this is a windmill whose speed will increase, more power to be fed in the network, and this will also cause the change in the power carrying capacity of these lines. And as the power fed by this generator is reduced, the power handling capacity of the lines will change. This is another example of two areas where these two areas are connected by two tie lines, and fault in one of the lines will cause increase in power flow in the other line, leaving little margin for excess power to flow. So through these examples, I just tried to explain how the present scenario in the system change, and in this changing scenario, depending upon the type of change, may increase in power or maybe decrease in power due to faulty condition, the generator outage, or if we are using a renewable energy resource, that was deliberate intention to bring in a renewable energy source where power input go on changing, maybe toward the upper side or lower side, and this will cause the change in power flow in various lines, and the operator has to keep watch on this, and if it has to take up any additional load or accepting any additional load, maybe in a single area case or maybe in the double area case, it will first decide whether there is enough margin to carry that load or not, and the electricity cost also may change depending upon the time, capacity of the lines, and the demand of the consumer. So, to define in words what you have seen uh, is given over here, the terminology available transfer capability refers to the power transfer capability remaining in the system over and above the existing transmission capability while providing for reliability margin. So the reliability margin is to be always taken into consideration while deciding how much additional power it can carry. As per अब ठीक है बाद में जरूरत होगी तो बोला. As per NERC and Indian standard, NERC stands for North American Energy Reliability Council, and Indian standard, the ATC of the system should be calculated while heading to N-1 contingency criterion. Means while defining the ATC, it is considered that even with the power flowing according to the defined contingency, it can sustain to N-1 contingency. That means even if a line goes out, it will carry the amount of power calculated through the ATC evaluation or ATC calculation method. The reliability margin incorporates to the capacity benefit margin and transmission reliability margin. The capacity benefit margin is defined as the amount of firm transmission transfer capability preserved by the transmission provider for load serving whose loads are located on that transmission service provider's system to enable access by the LSEs to generation from interconnected system to meet generation reliability requirement. Transmission reliability margin is defined as the amount of transmission transfer capability necessary to provide reasonable assurance that the interconnected transmission network will be secure. The TRM, that is transmission reliability margin, accounts for inherent uncertainty in system condition and the need for operating flexibility to ensure a reliable system operation as condition change. The existing transmission commitment, the first term which was used, any combination of native load uses contingency resistance, the margin, or capacity benefit margin, existing commitment for purchase, exchange, delivers, or sales, existing commitment for transmission service, and other pending potential uses of transfer capability. Actually, with this definition and the calculation method, which we will discuss later, the basic idea of this work, as I told you in the beginning, that the focal point is the evaluation of ATC in real time, where with the examples it will be demonstrated on RTDS real-time digital simulator, where part of it will be the artificial intelligence technique as well. So the work is to real-time estimation of ATC using PMU data and ANN. And ANN architecture for real-time estimation of ATC has been discussed in this example, which I told you just now. The real-time data obtained from PMU is utilized to generate target output using pattern search optimization based method. The set of information provided as input to the pattern search based ATC optimizer along with its output forms the input and the target output of ANN training. The input information consists of active and reactive power injected along with voltage and current vectors measured at the PMU. Whatever coming from the PMU, that becomes the input, and the calculated value of ATC forms the output for the ANN training. And later, when the neural network is trained, it directly makes use of the PMU data as input, and the ATC as output is calculated from the trained neural network information. The ATC optimizer is functional as long as AN is under training. Once the ANN is trained, it receives input set directly from PMU and produces ATC value, which I told you just now. PMU emulation is employed for archiving the PMU data. The proposed method is tested on modified IEEE 14 bus, IEEE 30 bus, and IEEE 118 bus standard systems. The proposed method has also been implemented on real-time digital simulator, which I told you just sometimes earlier. A method for real-time estimation of ATC by implying measurement data from PMU. This is expected outcome from the considered case study. A PMU emulator for obtaining the data required for training and testing of ANN-based real-time estimator. Feature extraction for ATC estimation in feasibility of real-time applicability of the proposed method has been authenticated by implementation on RTDS. ATC's definition, and of course it has already been defined, the power that could be delivered in addition to the existing transmission commitment with due adherence to the transmission reliability margin and capability benefit margin has been defined as ATC. That means mathematically to express ATC is ATC equal to TTC minus CBM plus TRM minus TTC. That is total transmission capability minus capacity benefit margin plus total reliability margin minus existing transmission capability. That is in equation 1, CBM and TRM depend on the system states and methods employed for their evaluation. ATC is significant for both economic as well as operational aspect of power system. The ATC is existing transmission commitment. That is true with some, whenever you evaluate, the lines may be carrying some amount of power. So the over and above, whatever the system can transmit is the available transfer capability. As far as the economy is concerned, am I audible?
Yes, sir.
Okay. As far as the economy is concerned, the adequate information of ATC would allow the maximum transaction of power, in turn resulting in revenue maximization and ensuring the system security simultaneously. The problem which we will attempt in future as formulated as the value of ATC in one that was that has already been expressed, the ATC value which is TTC minus two terms in the bracket minus ETC can be obtained by maximizing the demand in the sink area of the system expressed mathematically as Fx equal to Xi, I varying from 1 to sink, that is load in the sink area, minus the Xi0, that is load in the beginning. So that amounts to say that maximize the amount of power that the system can carry, which is mathematically written over here, the difference in sink and the sink area in the beginning and in the during the period it functions. And sink is the number of buses in the sink area that the load. Xi is the load at ith bus. Xi0 is the initial load, or you can say base load at the ith bus. The constants are the equality constant, that is power balance, where generation minus demand minus losses equal to 0. That is about active power. Similarly, for the reactive power, generation demand minus load. Inequality constant, that is the generation at a generator load should lie between its maximum and minimum limit that it can generate. Similarly, the reactive power generation limits voltage magnitude limits line flow limits and the load limits, and M is the number of generator buses and N is the number of load buses. Through three area, the power flow from one area to the other area are in general source to sink area is shown over here. Similarly, when the source is toward the other side and sink is toward its opposite side, this is the pattern search optimization technique which I told you in the beginning. So lot of measurements are coming from the PMU, and if all are used for the training, it will take a huge amount of training time. To reduce that, the pattern search minimization technique has been used, which extracts the features on which the load depend the relation of ATC depend to the maximum extent. That's what was told in the beginning, that the pattern search optimization technique will also be used to sort out the features which strongly define the ATC. Now, consideration of contingency, the probable outage failure or mal-operation of any component of power system is called power system contingency. The N-1 criterion for contingency analysis which I told you that if the one of the line goes out and which line and all that will be tested by the contingency ranking. So n minus one criterion for contingency analysis says about n minus one criterion mandates the power system operating under single equipment contingency to maintain the operation condition with limits and maintains the stable operating conditions on further using subjected to additional one contingency. Incorporation of contingency during ATC evaluation. To ensure proper operation, it is essential to consider the contingency while evaluating ATC of the system. So, thus the ATC for any transaction is evaluated for any system such that in the event of the occurrence and the contingency n minus one of the system remains within their operational limits. Therefore, contingency is screening for identifying the critical contingencies which are most sensitive to any given transaction has to be performed. This has been achieved by using it. The contingency screening means when it was said that n minus one contingency and evaluate when a particular line goes out, what how the system will behave, will its line or none of the lines will carry power more than its limit. To check that, contingency screening is performed in the beginning itself. Contingency screening means the contingency before actually find out the what happens after contingency. All the contingencies are ranked in the priority order of priority or severity. And suppose a contingency is most severe based on its ranking, means if this contingency happens, the other contingencies will cause less severeness to the system. So if the system survives for the most severe contingency, operator know that it will definitely survive to others. As a result, contingency screening is done in the beginning and the system is studied for the most severe one. If it survives, there is no need of studying the effect of all the contingency. That is what the screening means. And for this, a index has been defined by PIC, whose relation in terms of the voltage and the current and the exponent 2E is given over here. where the individual terms in the bracket are defined here. And the system and the line for which the where as the lower than the top one. So this ranking is obtained in the beginning before actually the contingency analysis is carried out, and this is to evaluate the contingency, taking care of all the cases. The data of ATC for varying scenario have been archived by the pseudo PMU emulator. Actually, the method used over here is a simulated PMU called the pseudo PMU emulator, which for which the method has been developed by one of the PhD student, Mr. Devesh Shukla, and this work has already been published in IET GTD. So now public the figure means how the data is created for ATC evaluation, and the input data from the PMU emulator is obtained, and the network solver which finds out the value of ATC using the formula which was explained earlier. So corresponding to all the scenarios using the relation which I told you has already been given over here, and its implementation in a flowchart manner is given in figure 4. So the information given to the PMU is, or the say here, the input information to the network solver is branch connectivity, voltage data, and the current data. And based on that, the current magnitude and its angle, at the branch current and magnitude and angle, and the voltage magnitude and angle, these information are obtained by PMU. And these are the information VIPQ, which is measured by PMU is shown in the slice over here, for which the quasi-static scenario, operating scenario has been created, from which the PMU measurement is recorded, and this PMU data, the network is trained, neural network is trained. Now to demonstrate that the pseudo PMU emulated in, and the actual power flow run using gradient technique, the time taken is same or more or less. You can see that the time taken by the PMU emulation is minimum compared to the gradient or iterative algorithm. So as far as speed is concerned, the PMU, that is pseudo PMU, has given faster result compared to any conventional technique. So one can adapt, that was the idea, the PPMU based measurement. Linear state estimator has been used for the online application, which if I go, we may not be able to complete the information. So I will discard it here. This is the system actually used. Neural network has been used to train the network, and you may be knowing about the radial basis function network, that the radial basis function network is used as the neurons are used in the hidden layer, and the one layer is the input layer, and linear neurons are used in the output layer. So the radial function neurons receive input information and uh, transmit it through input layer to the next hidden layer. The hidden layer and the output layer consist of RBF and the linear neuron respectively. Each layer consists of several nodes and which are fully connected, and the relevant predecessor are successful using succeeding layer. Now, Muir-Penrose generalized pseudo-inverse method is utilized to obtain the weight between hidden and the output layer. Actually, why this Muir-Penrose method? Because the RBF neuron and the output neuron Of course, the number of neurons and the number of RBF neurons, this side, there is no problem. But the hidden neuron and the output neuron, the matrix formed is a rectangular matrix. And the rectangular matrix to inverse is not a straightforward method. You can invert a square matrix, but inversion of rectangular matrix is not straightforward, and for which some pseudo-inverse technique are to be applied. And in this work, this more Penrose generalized pseudo-inverse method has been used. So this is for calculating the inverse of the output neuron and the hidden neuron matrix. The Muir pseudo method has been preferred over the other methods such as LMS least mean square and linear least square regression etc. due to its overall training time and the generalized abilities. The property of method makes it suitable for the real-time application that is the present problem. The Gaussian kernel has been used for the radial basis function. The K-means clustering has been employed for determining the center and width of the kernel. This is the common practice. Still, the Gaussian kernel is used for this purpose. This is finally the neural network architecture for which the inputs are the branch current, magnitude and angle, and node voltage and angle, which directly comes from the PMU measurement, and output is the ATC value. So during the training, the ATC values are to be evaluated using the formula given in relation 8. And once the neural networks are trained, the straight PMU data is inputted to the neural network, and with the trend information, whatever output the output neuron produce is accepted as the output of the system. The input to the network mainly consists of 4 different types of data. These data are voltage, magnitude, and angle of the buses at which the PMUs are located. Now, here I want to mention that we have not assumed PMU to be present at all the nodes. The PMU locations has been taken on the basis of a optimal PMU placement method. And I have mentioned in the beginning that it is tested on IEEE 24 bus, 30 bus, and 118 bus. For all these buses, wherever PMU placement was achieved using a optimal PMU placement method, that is also the method was developed by one of our student, Satyan Pratap Singh. So this work is also published in IIT GTD. So the same location was assumed, and we assume that the PMU is placed at that location, and whatever measurement comes from those locations is that has been used. And since those locations has been decided considering that the complete system is observable. So from those points of view, it is assured that the data obtained is sufficient enough to give the information about the entire system. If there are M PMUs optimally located in the system, then there will be M voltage magnitude and M voltage angle. Similarly, there are R branches terminating or originating at the kth PMU bus, then the branch current input to this is about the input only. The size of the input vector would be 2 into M plus 2Ri, where I varies from 1 to M. The pass through the LSC for obtaining all the states of the system. Output of LSCs, that is V alpha, Vi, and beta I, is measured at D, which comprise large number of features. The training process involves the optimal determination of current and width of RBF neurons so as to meet the required criterion for error tolerance. Already been explained. Feature extraction, why was it required? Am I audible? आवाज कम होगा तो बता दीजिएगा.
Yes, sir, audible, sir.
Okay. The sparse filtering algorithm with a data matrix D having n rows and p column where they represent observations and measurement especially. Now to reduce the space, this is sparsity has been used. Now this is not so important. So step by step algorithm. So this is the complete diagram considering the training and the online implementation. You may see the upper part by dotted line. In this part of the diagram, the network is trained. And after the training is performed, training and testing, the difference is that all the information coming to the network, the network calculates the AT value level. After instruction A, the network is under training, and when the switch is put in this position B, it is under the shown, it is under the put under the actual process, not testing. That is, it continuously produce the result where it need not go for training. It is straight calculates the ATC value directly with the trend information, and this part is shown by dotted lines but with a smaller gap. The optimization engine is the optimal ATC value using pattern search optimization method and stores the ATC. And the ATC storage, the ATC value are stored sequentially to be used as a target output for ANN, which I have already explained. Concurrently, the PMU emulator interacts with PSN solver to archive the voltage, current, and PMU location buses. The LSC block sends the linear estimated series in any input block. It is to be clarified that the value under set of the PMUs, the ATC storage as target and the large input bus by the ANN input block, and the ANN are quasi-statically synchronized. This is just to mimic the synchronized information as in actual practice is obtained. This is depicted by placing a switch at what I have already explained, switch A and B's location. Once the network is trained, is used. Now, coming to the real-time implementation, the functioning of ANN estimator has been verified in real time using RTDS. The test system has been modeled on RSCAD. The actual system has been modeled RSCAD like the PSCAD. The RSCAD is especially developed for the RTDS and compiled on RTDS hardware. The different loading scenario have been sent to the RDS simulator from monitoring and control center that has been built in MATLAB. The control center issues the appropriate command signal corresponding to any change in operating scenario, maybe change in load, maybe change in generation, increase or decrease, that is sent to the control center. This is the entire diagram, the complete diagram for the real-time digital simulation. Here is your real-time digital simulator. This is the front panel and this is the back panel connection of various wires where the actual system simulation takes place in RS CAD and the this one is the MATLAB for monitoring and control. So monitoring and control signal are issued from this MATLAB. So we have two computers, one here and the other one here. And the measured data are coming from this Open ECA software through this one, and your RSCAD, the PSCAD sends the information to your RTDS from where the GTNet and SKT. GTNet stands for Giga Transfer Network and SKT stands for the socket. So this protocol is used to send the signal from the real-time simulator to the real world. This is the schematic representation. So the GTNet PMU have been placed at the optimal PMU location in the power system model using RSCAD software, which I told you. The RTDS uses GT Sync card to time stamp the measurement taken by GTNet because this provision of uh, automatically synchronizing the information measurement is not there. So that has been achieved through GT Sync. The PMUs could publish data in IEEE C37.118 protocol and send the data to other devices and applications such as PDC and open source PMU connection tester provided by GPA Grid Protection Alliance has been used to testing the generating PMU connection 5 API. The Open ECA sends the data to the monitoring control center using the client API. The ATC estimator running in the monitoring and control center has been used to estimate the ATC in real time. Case study, the method proposed in the paper has been simulated on Core i7 this computer. The real-time implementation implies RTDS simulator. The performance of the method has been manifested on IEEE 1430 and 1318 bus. Now the table 3 contains the information. Let us say table 3. This is the information about the various systems, the 24 bus, 30 bus and 118 bus, where the generation in a particular area, where the loads are there, where the PMUs are located, and the generation load on the various buses, and what is the margin before a load goes to its maximum value. So for the 24 bus and the 30 bus, the tie line flow from various areas are given over here. Still time is there. For every input scenario, load generation network topology and PMU location, different values of TTC, total transfer capability, corresponding to various contingencies has been obtained, that is calculated. These TTC values corresponding to minimum of voltage stability and thermal limits. So the total TTC has been calculated. On this basis, the TTC value corresponding to the server most contingency would be lowest, most severe contingency. For defined capability set of contingencies, TTC, such a selection of TTC or ATC calculation would guarantee the safer operation of the power system, as any other single output contingency would result to TTC and the ATC higher than rank 1 selection. So the ranking 1, that is rank 1 has already been the value of TTC and ATC has already been tested for top rank ATC. There are the three systems of the PMU's readings. Yeah, SFA has been used to reduce the size of the input feature. These are the ATC from transaction A1 to A2 for 24 bus, which was listed in the table. This one is the important one. You can see that how the figure on estimate of ATC loading bus and in area A2 during RTDS simulation of perhaps 24 bus system, and the loading has been decreased from this value to this value at this point at which was area 2 with amount 3 point something to lower than 2, then here from 2 to maybe 1.6 or 7, and at this bus from point maybe 6, 7 to more than 0.5 over here, and during this period and during that period to the end, how the ATC value has increased because of the decrease in load at the various intervals at various buses by different amount. But first decrement, this one, then second decrement, it has gone to this value, and third, it has gone to this value. So you can see that the real-time digital simulator has very clearly demonstrated the change in ATC value as the system load changed. So to conclude with, this आ जाओ खत्म है. So a framework for real-time ATC estimation using ANN has been presented with its application on IEEE 2430 test system and ATC optimization engine applying proposed method for estimation of ATC has been used for obtaining the ATC training data in offline stage of real-time estimator development. A PMU emulation algorithm for quasi-static analysis of power system using pseudo PMU has been employed and used to obtain the voltage and current states of the system. The information obtained from the PPMU has been used as an input of the real-time ATC estimator. The results have been authenticated using real-time digital simulation of IEEE 30 bus test system. Now, if you have any query, because I chose this topic because where PMU was used for ATC calculation and real-time simulator wherein without communication protocol, the data transfer from of the various control signals or control instructions cannot be transferred to the actual system where it is being applied. So if you have any query, you may ask.
So, dear participants, if you have any queries, please ask, or you can post in chat box also.
Is any attendee present or not?
I think, sir, no queries, sir. Thank you, sir. Thank you very much, sir, for your very valuable and informative lecture. So I think participants got some knowledge regarding the research also, sir. Thank you, sir, for spending your valuable time with us. Thank you very much, sir.
I would also be thankful if some part of it or some method of it is applied by some student.
Yes, sir.
Through these faculty members, or if any student is attending, I will be glad to see.
Okay, sir.
In future.
Thank you, sir. Thank you very much, sir.
Oh, thank you.
So, dear participants, third session of day 2 will start from 2:30 p.m. So please try to join at least 5 minutes before starting of the session. So resource person is Dr. Yogesh Singh Chauhan, KNIT Sultanpur.